If we have a look at this cuboid, this is spelt cuboid, then we've got to try to work out how many times we could cut this in half. So if I were to shove a mirror into this shape, then it would look the same on both sides of that mirror. And I could cut it halfway that way and halfway this way. And I could finish it off by drawing the dotted lines going through the shape like this. Now, by cutting the shape in half that way, that's introduced what's called a plane of symmetry. So plane of symmetry is spelt like that. The question is, how many different planes of symmetry could you have in a cuboid? By saying that it's rectangular, it's not really, that rectangular is the wrong word really, it should say oblong. Because a square is a rectangle, an oblong is not a square. So we can't, but by saying it's oblong, what it means is that no sides here are square. And that's quite important, because if it was square, then you could cut it diagonally. But because it's rectangular, you can't. Well, because it's oblong, you can't. So, where are the others then? It's difficult for me to draw them, so I've got them drawn further down here. You can see that the first one we drew was that one there. The second one is here. It could be cut in half in that direction, and the third one, of course, cut in half in this direction. So there are 3 different planes of symmetry in a cuboid. An interesting question for you is how many planes of symmetry there would be in a cube, and that is quite interesting. Oops, I'm going off the screen here a little bit. Yeah, how many planes of symmetry are there in a cube? That's something to consider. That's quite an interesting one. But there are 3 in a cube, an oblong cuboid. So let's look into the next case, which is a square-based pyramid. It doesn't look very square from the diagram, but all of these are the same length, and that's indicated with these little dashes on it. So how many different planes of symmetry could there be in this? But look in the question again. It says all the symmetries. It's not asking for all of the planes of symmetry. It's asking for all of the symmetries. So there may be more than just planes. Interesting to think about. But let's consider just planes first. Here are the ways that you could cut it. Because it's square now, you can cut it diagonally as well as cutting it in half. So you've got 2 diagonal ones and 2 cutting in half ones, in half parallel to one of the sides. So there are 4 planes of symmetry. But what on earth is the other symmetry? Well, symmetry means the same once you've changed it, once you've moved it or cut it. So can you try to work out what the other one is? This dot may give you a clue. Okay, here you go. This is the answer. It's an axis of rotational symmetry. That means if you put a string all the way through and you spun it around this string, then it would look the same 4 times. So there are 4 orders of rotational symmetry around the axis that is that dotted line. Interesting, huh? Okay, we're at the end. You can start the exercises.